Hi everyone, welcome to this section on hierarchical clustering. So this is the second kind of clustering after the k-mean clustering which we are going to learn. So what are the topics which we will cover in this section? So this is the list of topics which we are going to cover in this section. The first is the definition of the hierarchical clustering. So we will compare the hierarchical clustering with the help of k-mean. Then we will learn the steps of hierarchical clustering algorithm. So in this we will learn how to apply the hierarchical clustering on a data. Then we will learn hierarchical clustering on 1D data using D minimum criteria. So basically for hierarchical clustering, we have three basic type of criteria: the minimum distance criteria, the maximum distance criteria, or the average distance criteria. So we will first learn what is the minimum distance criteria, and we will learn this with the help of 1D data. Then we will implement hierarchical clustering again on 1D data, but this time we will learn using the maximum distance criteria. Then we will learn how to apply hierarchical clustering algorithm on a 2D data. Then we will learn dendrograms. So dendrograms are very important. So the first advantage of dendrogram is that they will help us to find the optimal number of cluster. If you remember, we use elbow method for k-means clustering in order to find the optimal number of cluster. So here we will use a dendrogram. The first advantage is that using dendrogram, we will be able to find the optimal number of cluster. And the other advantage is the dendrogram contains the memory of the clustering. So what is meant by the memory of the clustering, we will see when we will study the dendrogram. After the clustering and after the dendrograms, we will evaluate the performance of hierarchical clustering. And at the end, we will have 3 projects in Python on the hierarchical clustering. So there are quite a few number of topics which we are going to cover in this section. So I hope you will enjoy this section. I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we will learn about the definition of hierarchical clustering and steps involved in hierarchical clustering. So hierarchical clustering has two major kinds. These two kinds are agglomerative clustering and divisive clustering. So in this section of the course, we will learn only about the agglomerative clustering. So what is the definition of agglomerative clustering? So agglomerative clustering is a famous unsupervised machine learning algorithm which is used to group objects in clusters based on their similarity. So basically, like every clustering technique, in this clustering technique, we also group the data samples based on their similarities. So those data samples which are similar to each other are grouped in a one cluster and other are grouped in the other cluster. So in this approach of hierarchical clustering, each data sample starts with its own cluster and then pair of clusters are merged as one, moves up the hierarchy. So basically what happened at the start of agglomerative clustering algorithm, that we assign every data point its own cluster, and then we start merging the cluster based on the similarity, based on the distance, and then we move up so that we end up with a single cluster. So based on this approach, agglomerative clustering is also known as bottom-up approach because we start from a single data point and we consider that every single data point has its own cluster, and then we move up by merging the similar clustering together. So in order to understand this in a more appropriate way, let's understand the steps of agglomerative clustering. So these are the 4 steps of agglomerative clustering. Make each data point a cluster. That is, if we have n data points, we have n clusters. So the first point is that you consider each data point has its own cluster. So if we have n data points in a data set, it means we are starting this algorithm with n number of clusters. The step 2 is take the 2 closest points and make a cluster, and now we have n minus 1 cluster. So we start reducing the number of cluster. We have n data points and we have n cluster at the start of this algorithm. Then we start merging the 2 closest points and merge their cluster together to form a single cluster. In this way, we have n minus 1 clusters now. The step 3 is then take the 2 closest cluster and make them one cluster, and now we have n minus 2 cluster. So basically, as we move on, we are starting to reduce the number of cluster. We started with n clusters because we have n data points in a data set. Then we start reducing the clusters from n to n minus 1. Then we move on and keep merging the clusters which are close together. So in the next step, we will have n-2, n-3, n-4, and we reach to the point when we have one cluster. At that instant, the algorithm is converged. So these are the very simple steps in order to learn the agglomerative clustering. Now, in step 2, we see that we take the two closest point. Now, how to find the distance between the two closest point? So there are three methods. Either we go for minimum distance between the two clusters, maximum distance between the two clusters, or average distance between the two clusters. So the average distance will be calculated by calculating the distance between the centroid of the two clusters. Let's understand the concept of these three methods of measuring the distance between the two clusters. The first is minimum distance between the two clusters. So the minimum distance is the distance between the two data points in the clusters which are close to each other, which are very, very close to each other, or which are present at the boundaries of the cluster, as you can see in the figure. In this criteria, we call this criteria as a minimum distance criteria of calculating or merging the closest clusters. The next is the maximum distance between two clusters. So in maximum distance, we calculate the distance between the farthest point in both the cluster. You can see in this figure, that point is the far most point at the outer boundary of this red cluster, and this is the point at the outermost boundary of this blue cluster. So calculating the distance between the farthest point in two cluster is known as maximum distance criteria. So we can also use this maximum distance criteria between the two clusters in order to merge the clusters. We will see this with the examples in the coming lectures. The third criteria is to calculate the average distance between the two clusters. Now the average distance will be the distance between the centroid of a two cluster. So this is another way of merging the two clusters. We calculate the distance between all the cluster and we merge that which has the minimum average distance. So the average distance will be the distance between the center of a two cluster and the centroid of the two cluster. So in this lecture, we learn about the definition of agglomerative clustering, which is a very important type of hierarchical clustering. We learn the four important steps of agglomerative clustering, and we discuss that how to merge the cluster. So we learn that there are three techniques. Either we use minimum distance criteria, maximum distance criteria, or average distance criteria. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. In this lecture, we are going to implement agglomerative clustering on a 1D data. We will learn this with the help of a numerical example. So here is my numerical example. We have a data set containing only 6 points, 5, 6, 9, 11, 18, and 22. And we are going to apply minimum criteria to form the cluster. So these are my 6 data points in my data sample. So all these points are in 1D. So let's start implementing agglomerative clustering algorithm. So the step 1 is to assign a cluster to each data point. So I have 6 data points. So at the start of this algorithm, I will have a 6 cluster and I will start reducing the cluster from 6 to 5, 4, and so on, so that at the end of the algorithm, I will get only one cluster. So the step 2 is to find the minimum distance between these clusters. Since I have 6 clusters, therefore the distances will be 5. That is, the distance between 5 and 6 is 1. The distance between 6 and 9 is 3. The distance between 9 and 11 is 2. The distance between 11 and 18 is 7. And distance between 18 and 22 is 4. So this is the set of minimum distances. And from this set of minimum distances, we have to select a one which is the less distance, or which is the minimum distance out of all these minimum distances. The minimum distance is 1, which is between 5 and 6. So we will merge them to get a single cluster. So here we can see that now we are left with 5 cluster at the end of the step 2. So at the start of step 1, we had 6 cluster. We calculated the minimum distances, and based on the minimum distance, we merged the clusters, and now we are left with 5 clusters at the end of step 2. Let's move on to step 3. So step 3 will be start with the distances between the cluster. So I have now 5 clusters at the end of step 2. It means now I have to calculate the 4 distances. So the distance between 6 and 9 is 3. The distance between 11 and 9 is 2. The distance between 18 and 11 is 7. And the distance between 22 and 18 is 4. So these are the new 4 distances which are shown here. So this is the distance between the cluster 1 and 2 at the end of step 2. That is the distance between 9 and 6, which is 3 as shown here. So out of these 4 minimum distance, the minimum is 2. Now this is the distance between 9 and 11, and you can see that we have already merged them after calculating the minimum set of distances. So in this way, we are reducing the number of cluster. In step 1, we started with 6 cluster. Then at the end of step 2, we were left with 5 cluster. And now at the end of step 3, we have only 4 cluster. So step 4 will be started by calculating the distances between these 4 cluster now. So the distance between first 2 cluster at the end of step 3 is 3. The distance between 9 and 6 is 3. The distance between 18 and 11 is 7. And the distance between 18 and 22 is 4. The minimum distance from this set is equals to 3. And this is the distance between these 2 clusters. So at the end of step 4, we can merge these 2 clusters in order to get 3 clusters. So we still have 3 clusters. So we will continue our step 4. So the first step is, or the next step is to calculate the distance between these 2 clusters, which is 7. And the distance between these 2 clusters will be 4. So we will merge these 2 clusters now. So we can see that the minimum of 7 and 4 is 4. So we will merge 18 and 22. Now we have only 2 clusters and the distance between them is 7. So the final step is to make a single cluster out of these 2 clusters. Here the algorithm is converged and we have implemented all the 4 steps of agglomerative clustering, which we saw in the previous lecture. Now the question is, we have only one cluster. It means that all the data points belongs to same type, or they have the similarity between them. The question is, if we have 100 data points and we start with 100 cluster and keep on reducing the cluster after every step, we will also end up with a single cluster. Now, where to stop and how to find the optimal number of cluster, we will study this in the next lecture. See you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we will learn how to find the optimal number of clustering in hierarchical clustering. So we will study dendrograms. So what are dendrograms? So dendrograms will help us to find the optimal number of clusters. So dendrograms are diagrammatical view in which clusters are obtained in the hierarchical order. So basically what we will do, we will solve the same example as we did in the previous lecture, that is 1D example. So we will make a cluster, and in the same way, we will also make a dendrograms in parallel. And we will see how dendrograms will help us to find the optimal number of cluster. So this is my data set which I used in the previous lecture, that is 1D data. It has 6 points. So here I am forming a cluster and here I am forming a dendrograms. So at the start of the algorithm, we will make a cluster, or we will merge those 2 points which are closest to each other. So here is the cluster of 5 and 6. Here we have merged point 5 and 6. So this is the dendrogram. So this is the method of the dendrogram, how to draw the dendrogram. So the height of the dendrogram show the distance between 2 clusters, or the dissimilarity. Smaller the distance, smaller is the dissimilarity. Since 5 and 6 is a very small distance, there is a 1 unit difference between 6 and 5. So we can see that this height of dendrogram is very less. So basically what we are going to do, we are making a cluster, we are implementing a agglomerative clustering algorithm on 1D data, and in parallel we are also drawing the dendrograms. So at the end of the algorithm, the dendrogram will help us to find the optimal number of cluster. So the next step is to combine the next 2 closest points. So the next 2 closest points are 9 and 11. So here you can see that I have merged these 2 points, 9 and 11, and here is the dendrogram of 9 and 11. So the distance between 9 and 11 is 2. whereas the distance between 5 and 6 was 1. Therefore, the height of dendrogram for the points 9 and 11 is higher or greater than these 2 points 5 and 6. Now, the next step is to merge the two closest cluster. Now, these two red and blue cluster are closest because the distance between these two cluster is 3, that is 9 minus 6. And here the distance is 7 and here the distance is 4. Now merge these two clusters to form a single cluster. So in dendrogram, we will draw like this. So as we move on, we are making the cluster and we are also drawing the dendrogram in parallel. So we can see that we have start reducing the number of cluster, and now we have a cluster here and these two. So we have basically 3 cluster, 1, 2, and 3. The next step is to combine those two clusters which are closest. So here 18 and 22 are the closest distance because the distance between 18 and 11 was greater. If I go back, this distance is 7 and this distance is 4. So I will combine these two clusters or these 2 points to form a cluster or to merge a cluster. So here is another cluster between 18 and 22, and this cluster is shown in dendrograms as well. So we are merging the clusters and we are drawing the dendrogram. So the last step is to make a single cluster out of these. So this is the last step of agglomerative clustering. And here we can see that with the purple, this is the final form of the dendrogram. So here we have reached to the end of the agglomerative clustering algorithm and we have also completed the dendrogram. Now how this dendrogram will help us to find the optimal number of cluster. So in order to find the optimal number of cluster, we have to set a threshold. So how to set a threshold? So basically for setting a threshold, see the largest vertical line which does not cross or interfere any horizontal line. So first of all, see the largest vertical line in dendrogram diagram. So the largest vertical line could be either this line, and this purple line. But the condition is we have to select that largest vertical line which do not cross or interfere any horizontal line. So these two lines are crossing or interfering the horizontal line. If I extend this blue, red or green horizontal line, we can see that these line will cut this vertical line, or we can see that this vertical line is interfering these 3 horizontal lines. So based on this criteria of selecting threshold, we cannot select these 2 vertical lines. If I want to select now this vertical line, again, this is not following the criteria, because if I extend this horizontal line, it will interfere this vertical line. So I am left only with this vertical line. So I have to set the threshold here. So how to set the threshold? Draw a threshold horizontal line so that we can move across the dendrogram from start to end. So this is my threshold line. We select this vertical line because this vertical line do not cross or interfere any horizontal line. So we select the threshold. After selecting the threshold, we have cut this dendrogram, and now we have this separate portion and this separate portion. So basically, by cutting this, what we can see that after a threshold line, we have two, or below the threshold line, we have 2 vertical lines. So this vertical line form this cluster and this vertical line form this cluster. It means for this particular example, we have 2 clusters, 5, 6, 9, 11. They form a one cluster, and 18 and 22 form a separate cluster. So this is our final cluster, and this is rightly so because these 4 points are close to each other as compared to these 2 points. These 2 points are close to each other as compared to these 4 points. So in this way, by using a dendrogram, by drawing the dendrogram step by step, we reach to the point where we apply the threshold value, and based on that threshold, we were able to select the optimal number of cluster. So I hope you understood this lecture. You understood how to form the dendrograms, how to select the threshold line, and from the thresholding, how to select the optimal number of cluster. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So this lecture is considered as the continuation of the previous lecture. So in the previous lecture, we were trying to find the optimal number of clusters from the dendrogram. So in order to find the optimal cluster from the dendrogram, we have to set a threshold, and there are two conditions for setting a threshold. First of all, we need to find the largest vertical line. Now, this could be the largest vertical line in this dendrogram, or this could also be the largest vertical line. The other condition is that the selected largest vertical line should not cross or interfere any horizontal line. So if I select this as a largest vertical line, I cannot select this. The reason is if I extend this horizontal line, it will pass or interfere through this vertical line. It means I cannot select this vertical line for my thresholding. Now it's time to check this vertical line for a thresholding. If I see that I cannot also select this vertical line, the reason is if I extend this horizontal line, it will pass or interfere through this vertical line. Now I am left with this vertical line, and I can see that this vertical line is a correct selection because there is no horizontal line which pass or cross or interfere this vertical line. So here I draw my threshold line, which is a horizontal line. After drawing this threshold line, which is crossing or which is passing across the dendrogram, I see that there are two vertical lines below this threshold line. And based on these two vertical lines, I selected two clusters. So that was my first cluster and that was my second cluster. So in this way, in the previous lecture, we selected the optimal number of cluster with the help of dendrogram and with the help of thresholding. Now the question is that the only possible solution, or is there any possibility to have more than two clusters? So let's see it again very carefully. If I see this vertical line, after at this point, this vertical line is further subdivided into two vertical lines. So I may select this 5 and 6, these two data points as one cluster, these two data points as second cluster, and these two data points as a third cluster. So there is another possibility that from this dendrogram, we can also select three number of clusters. If I select three clusters, so they will be look like this. 5 and 6, these two data points form a first cluster, then we have a second cluster, and we have a third cluster. Now the question is, which choice is better or which choice is optimal? Whether the choice of three cluster is better or the choice of two cluster is better. So in order to justify our selection, we have to evaluate the performance of this hierarchical clustering. So basically, in order to evaluate the performance of hierarchical clustering, we have a metric known as Silhouette score. So we will study this Silhouette score in the coming lectures of this section. So what we will do, we will calculate the Silhouette score for three clusters, and we will also calculate the Silhouette score for two clusters. And we will select the number of cluster which has high Silhouette score. So if the Silhouette score value of three cluster will be high than the two cluster, then we will select three cluster. So what is happening here is basically dendrogram can be misleading and can create a confusion. But we should try our best to select the best number of cluster. And after selecting the best number of cluster, we don't need to worry about, because we have a evaluation metric known as Silhouette score. We calculate the Silhouette score and we select those number of cluster which has high value of Silhouette score. Now look at this dendrogram. Now this dendrogram is very large and is very complex. And we can see that it is formed from a large number of data set. Now, where is a threshold line and how to draw a threshold line on this dendrogram? Now we have to select the largest vertical line. So we can see that this is the largest vertical line. Now the question is, can we select this vertical line? The answer is no, because if I extend this horizontal line, it will cross this vertical line. So I cannot select this vertical line for thresholding. After that, I have this vertical line. I cannot also select this vertical line because if I extend this horizontal line, it will cross or interfere this vertical line. So I am left with this vertical line now. If I want to select this vertical line, I cannot select this vertical line because if I extend this horizontal line, it will cross this vertical line. So now I am left with this vertical line and this vertical line. I cannot select this vertical line because if I extend this horizontal line, it will interfere. Now I am left with only this vertical line, which is the largest left vertical line in the dendrogram. So I can see this is fulfilling the requirements of a thresholding. So here is my threshold. Now the question is, if I draw a threshold here, how many clusters will be possible? So if my threshold is here, you can see this is my threshold. So if my threshold is here, so this is my cluster 1, this is my cluster 2, this is my cluster 3, this is my cluster 4, and this is my cluster 5. So based on the thresholding from this dendrogram, I am going to select 5 clusters. There may be a possibility of a 4 cluster, like this will be a first cluster, this will be a second cluster, this will be a third, and this will be a fourth. So again, the dendrogram may be confusing and may be misleading, but you have to try your level best to select the optimal number of cluster from the dendrogram. And you don't need to worry about after the selection, because we can always justify our selection by calculating a Silhouette score. So in this lecture, you see the dendrogram can be complex, the dendrogram can be large, and it could be difficult to select a threshold line on a dendrogram. And after selecting a threshold line, it could be difficult or it could be confusing to select the optimal number of cluster. So in order to solve all this problem, we have a metric known as Silhouette score to evaluate the performance of hierarchical clustering, and we will study this metric in the coming lectures of this section. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are again implementing hierarchical clustering on a 1D data, but this time we are using a maximum distance criteria between the cluster in order to merge the cluster. In the previous 1D example, we used the minimum criteria to merge the cluster, and now we are using the same example, but we are using the maximum distance criteria to merge the cluster. So this is the same example. I have a data set with 6 points, 5, 6, 9, 11, 18, and 22. But the most important thing or the change is here that we are using the maximum distance criteria method to form the cluster. So what is the definition of the maximum criteria distance and how we will apply? So this is very important to understand. The maximum distance means to find the minimum value from the set of maximum distance between the cluster. Now, what does it mean to find the minimum value from the set of maximum distance? So basically here, if you can see, we will make a set of maximum distance, but from that set, we will select the minimum distance. So this is very tricky. That's why be attentive and be careful in order to understand this example. So we will make a set like we did in the previous 1D example, but this time the set will be made using maximum distances. When the set is made, then we will select the minimum value. So let's start this example and apply all the steps of hierarchical clustering. So the first step is according to the step of the algorithm. The first step is to assign each data point a cluster. So I have 6 data points. So I have assigned each data point a cluster. So I am starting with the 6th cluster here. So the step 2 will start to find the maximum distance between the cluster, because we are following a maximum distance criteria in this example. Now here the advantage is, since every point has its own cluster, so here the maximum and minimum distance are same in step 1. So the distance between 5 and 6 is 1, whether you can call it a minimum distance or a maximum distance. So for step 1, the maximum and minimum distance is same. So the distance between 5 and 6 is 1, then 6 and 9 is 3, then it is 2, then it is 7, and then it is 4. So this is a set of a maximum distance, and from the set of maximum distance, you will select the minimum value, which is 1. And this value is between cluster 5 and 6, or between data point 5 and 6. Now we merge these 2 points, and now we have 5 cluster. So here I am copying the step 2 again, so then we can clearly understand step 3. So this was my step 2, where the minimum distance was 1, and I have merged cluster 5 and 6. Now step 3 will start by calculating the maximum distance between the clusters that are obtained at the end of step 2. Now here we have to find the maximum distance. Now this is one cluster and this is the second cluster. The maximum distance between these two clusters is 4. Keep in mind, we are solving this problem by using a maximum distance. And the minimum distance between these two clusters is 3. So I am using the maximum distance. That's why the distance between first two clusters is 4. And you can see that this is 4. The distance between these two clusters is 2, whether you can call it minimum or maximum. So here for these two clusters, the minimum and the maximum distance is same. It is 2. It is 7 for these two clusters, that is between 18 and 11. And it is 4 between these two clusters. So this is a set of a maximum distance. And what is the definition? That first we made a set of a maximum distance, and then we select the minimum value from this set. So the minimum value is 2, and this 2 value is between 9 and 11. So we will merge 9 and 11. Now move on to step 4. So step 4 will start by calculating the maximum distance between the cluster. Now I have 4 cluster. 4 cluster means now I will have 3 distances in the next set. So calculate the maximum distance. Now here the clusters are merging, so you have to be careful. The maximum distance between this red cluster and the blue cluster is 6. How it is 6? It is 11 minus 5. So you have to be careful because you are making a set of maximum distance. And the maximum distance between these two clusters is 9. That is 18 minus 9. So the distance between these two clusters, the maximum distance is 6. And between these two clusters is 9. And between these two clusters is 4. So let's see this distance. So these are 6, 9, and 4. And this is a set of a maximum distance, but from the set of a maximum distance, we have to select the minimum value. So the minimum value of this set is 4, and this 4 is between 18 and 22. So this is between 18 and 22, and you can see that we have merged these clusters. Now we are left with 3 clusters. It means we have to find 2 distance. Again, we have to find, or we have to make a set of a maximum distance, and from that set of a maximum distance, we have to select the minimum value. So the distance or the maximum distance between these two clusters is 6. 11 minus 5 is 6. And the distance between these two clusters is 13. How it is 13? 22 minus 9 is 13. So these two are the maximum value of distances between these 3 clusters. And the minimum of them is 6. So I will merge these 2 clusters to form a single cluster. And the final step is to find the maximum value between these 2 clusters, which is 22 minus 5, which is 17. So I will merge these 2 clusters to form a single cluster where the algorithm is converged. So student, in this way, you see that we have find a single cluster and we have reached to the point where a single cluster is formed using the maximum distance criteria between the cluster. Now the difference is here. If you remember the previous example, we do not have 3 clusters at any stage of the algorithm. If you go back in the previous lecture and see the minimum distance criteria, where we have this cluster and this cluster only, we do not have. So basically we have reached to the final cluster, which is always the end of the agglomerative clustering. But here we have reached to this final step in a different way as compared to the minimum. So we have only 6 points. Even then we can see the difference between the formation of cluster using the minimum method and the maximum method. Now the next step is to use dendrograms to set the threshold and find the optimal number of cluster. So we know that how to form a dendrogram. So here I am solving this problem in parallel. I am making the cluster and I am drawing the dendrogram. So the first step was to combine 5 and 6. So this is the cluster formation and this is the dendrogram formation. Here the second step was to combine 9 and 11. So this is the dendrogram formation. So the next step was to combine 18 and 22. So here is the dendrogram formation. The next step was to combine these 2 clusters, that is red cluster and a blue cluster. So here you can see that we have combined these 2 clusters with the help of a dendrogram. The next step is to make a single cluster out of these 2 clusters. So this is our next step. So this is our final cluster and this is our final dendrogram. So from the previous lecture where we study how to find the optimal number of cluster using dendrogram, we will use the same method. That is, we will find a vertical line which has a maximum length. So in dendrogram, there are more vertical lines than the horizontal lines. So the thresholding step is to find the maximum vertical line or a vertical line having a maximum length in dendrogram, which do not cross or interfere any horizontal line. So that is the definition, or that is the concept of finding the threshold. If I select this line, this seems to be the maximum line. But the thing is, this line could be interfere if I extend this horizontal line. So based on this, I cannot select this line. So I am left with this line. So this is my vertical line, which is the maximum line in this example. So if I take a threshold here, if I draw a threshold here, remember the previous lecture, the threshold is a horizontal line which move across the dendrogram. So if I move a threshold here, if I select a threshold here, so beyond or below the threshold, I have this one cluster and I have one cluster here. The other possibility could be that I can make this cluster, and this cluster as well. So here we can make a 2 cluster, or we can also make a 3 cluster. But the best is that based on this vertical line, make this as a 1 cluster and make this as a 1 cluster. So this is our final solution, and you can see that this is a threshold. So you can see that threshold has moved across the dendrogram. We start from that vertical line, which is of maximum length in our dendrogram. We extend this line to the other line. So here we have selected this as a 1 cluster and selected this as a 2nd cluster. Now, student, we will see dendrogram many times in this section of hierarchical clustering. This could be a 1 cluster also. We will discuss this in the coming slide, and this could be another cluster also. So basically, we can select 2 cluster or 3 cluster, and then we can evaluate the cluster, that whether the 2 clustering choice is best or a 3 clustering choice is best, because we know from the previous section of k-means clustering that we have a CH index which tells us which cluster choice is better than the other. So if we select 2 cluster here, that is 1 cluster this and 1 cluster this, this is also the optimal choice of cluster. And if I select 3 cluster here, this is also an optimal choice, because we can see that this is another group of the points, this is another group of the points. So if we select 2 cluster and then 3 cluster, so we are not going in the wrong direction. After that, we can evaluate and see whether the choice of 2 cluster was better or a choice of a 3 cluster was better. So in this lecture, you learn how to apply the maximum criteria of a distance to merge the cluster. We solve the same 1D example which we solved for the minimum distance criteria. And after that, we reach to the point where we have a final dendrogram here. We draw a threshold, and based on the threshold, we select the optimal number of cluster. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to apply hierarchical clustering algorithm on 2D data. Previously, we have applied this algorithm on 1D data. Now it is time for 2D data. So this is my 2D data. We can see that we have 6 points from P1 to P6, and these points are in 2D coordinate, or these points are in 2D dimension. The first dimension is along x1 and the second dimension is along x2. Now we know that if we want to find the distance between 2D points, we need to use the Euclidean distance equation for 2D. So this is the equation which we used in k-mean clustering sections as well. So here I am not using this equation because I am not solving a numerical example on 2D. I just want to explain you intuitively that how k-mean clustering works in 2D. So I have 6 points in 2D. It means every point has 2 coordinates, that is one coordinate along x1 and another coordinate along x2. So the first step is to merge those 2 points which are closest to each other. So we are using a minimum distance criteria, which is the most commonly used. And in the coming lectures, we will only use the minimum criteria to merge the cluster. So here we can see that point P2 and P3, these are the 2 closest points. So here we are not calculating the distances to find the closest point because we do not have the coordinates value. We are doing this intuitively, and the purpose is just to get the concept how hierarchical clustering work in 2D. So the first step is to merge these 2 points to make a single cluster out of them. So this is the first step. Here you can see that I have merged P2 and P3 into a single cluster. So the next step is to find two more closest points. Now here we can see that P5 and P6 are the two most closest points. So we have merged this P5 and P6 into a single cluster. So the next step is to merge two more closest points. So the next closest point or the clusters are P2, P3. So this cluster, the red cluster, and P1, these are the most closest cluster or a point. So we can see that we have merged these 3 points into a single cluster. So the next step is to merge two more closest points or two more closest cluster. So here we can see that P4 is closest to this cluster as compared to this cluster. So we will merge P4 with the cluster of points P5 and P6. So here we can see that we have merged P4, P5 and P6. Now we have two clusters. We will combine them to make a single cluster so that the algorithm is converged. So here is the final solution or the final step of hierarchical clustering in 2D. So we have seen that we started from the 6 data point, that is from the 6 cluster. We start reducing and we have reached to the point where we have a single cluster for all the data points. Now it's time to find the optimal number of cluster. And you know that for the optimal number of cluster, we need dendrograms. So here I have shown you the complete set of dendrogram, and this was the steps of clustering. If you remember, first we combine P2 and P3. So that was the first step. Then we combined P5 and P6. That was the second step. So the third step was to combine P2, P3 and P1. That was our third step. You can see that 3 is written where we combine P1, P2 and P3. So the fourth step was to combine P4, P5 and P6 or to merge these points in a single cluster, and you can see that. And the final step was to merge these two clusters to make the final cluster. So if you see the dendrogram, so this is the step-by-step dendrogram of this clustering algorithm. So you can see that in order to get the optimal number of clusters, we need dendrogram. The other advantage of dendrogram is that the dendrogram contains the memory of the hierarchical clustering. If you see the dendrogram, you can see from where you start. If you see this figure, you cannot realize easily that which was the first step. It may be P2, P3 or P5 and P6. But if you see the dendrogram, you can see the memory or the history of the cluster making. So you can see that this was the first step, that was the second, third, fourth, and fifth. So in this way, we can see that the hierarchical clustering or the dendrogram of the hierarchical clustering not only help us to find the optimal number of clustering, but they also help us to see the memory of the clustering. So what we can do here? So here, basically, the last step is to set the threshold. For the threshold, we have to find or we have to see the maximum vertical line or the vertical line which has the maximum length and which do not interfere any line. So here we can see that this is our maximum vertical line. So this is our maximum vertical line which do not interfere any horizontal line. If I select this as a maximum vertical line, but this line will be interfere if I extend this horizontal line. So my threshold will be here. So I leave it to you as a practice that how to set a threshold, because you have seen already two examples where we set a threshold for the dendrogram. So here you can see that you can easily find a threshold here, and then you can select the number of clusters. That is, this will be the first cluster and this will be a second cluster. So I leave it as a practice for you to set a threshold here and to find the optimal number of clusters. So in this lecture, we learn how to implement hierarchical clustering on a 2D data. We see that we had 6 points and we intuitively build clusters on that, and we keep on merging the points until we reach to the final cluster. After that, we draw a dendrogram as we learned in the previous lecture. From the dendrogram, we see that the dendrogram not only help us in finding the optimal number of clusters, but it also contains the memory of the hierarchical clustering. After making a dendrogram, we can set a threshold and we can find the optimal number of clusters. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So far in this section, we have learned how to implement hierarchical clustering algorithm on 1D data and 2D data. We know how to find the optimal number of clusters using dendrogram. Now it's time to evaluate the performance of hierarchical clustering. So the metric which we are going to use in order to evaluate the performance is Silhouette score. If you remember in k-mean clustering algorithm section, we use CH index to evaluate the performance of k-means clustering. You can also use CH index here to evaluate the performance of hierarchical clustering, but let's learn another metric, which is Silhouette score. So this is the definition of a Silhouette score. If you see, it is the ratio of two quantity. In the numerator, we have a difference between B minus A, and in the denominator, we have to select the maximum value between A and B. So A is the average intra-class distance, that is average distance between each point within a cluster. B is the average inter-cluster distance, that is the average distance between all the clusters. So here, if we have two clusters, it means B is the inter-cluster or between cluster distance. It is the average distance between the two clusters. So how to find B and how to find A? So let's understand first how to find B. So B is the average distance between the two clusters. So how to find the average distance? So it is very easy. Basically, B is the distance between the centroid of the two clusters. Whenever we calculate the distance between the centroid of a two cluster, it is considered as an average distance between the two clusters. So this is the way of finding the value of B. Now, A is the intra-cluster distance, that is the average distance between each point within a cluster. So the way to find the A is, we have a centroid here. Calculate the distance of each point with its centroid, and then you can take the average of all the distances. So this is within cluster distance, or this is called intra-cluster distance. The B is called inter-cluster distance or between the cluster distance. So in this way, we can easily find B and A, and then we can use these metrics to find the Silhouette score. Now, what is the best value of a Silhouette score? So the range of Silhouette score is between -1 and +1. -1 is considered as a worst value and +1 is considered as the best value. So it is said that any value greater than 0.6 is considered as a best value for a Silhouette score. Suppose you have a cluster and you get value close to 1 or exactly 1. So if you get the Silhouette score 1, it means the cluster are well apart from each other and they are clearly distinguished. If you have a 0 value or close to 0 value for a Silhouette score, it means the clusters are overlapping and they are not separating very well. So 0 is not considered as a good value. When we get a 0 value in Silhouette score, it means the clusters are overlapping. The 1 value is considered as the best. It means the clusters are well separated. If you get -1, this is considered as a worst value for Silhouette score. It means you have assigned a wrong cluster to a sample. So this is totally unacceptable, the -1 value. So in this lecture, you learn how to calculate the Silhouette score. You learn that there are only two distances you need to calculate in order to find the Silhouette score for hierarchical clustering. So these distances are B and A. B is the average distance between the two clusters. It is called between two cluster distance or inter-cluster distance. A is the average distance within the data points of a cluster, and it is also known as average intra-cluster distance. Silhouette score ranges between -1 and +1, with -1 as a worst value and +1 as a best value. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So in this lecture, we are going to implement hierarchical clustering in Python. So this is our project 1 related to hierarchical clustering. So here I am in my Google Drive, and this is my course folder. Click on this, and inside this course folder, I have a folder known as unsupervised machine learning. Click on this folder, and here I have hierarchical clustering folder. Click on this folder, and here is project 1. Click on project 1 so that we can open it in our Google Colab environment. So this is our project 1 in Google Colab environment. And these are the important files. These are the important Python files or Python libraries which I need for project 1. So I am importing NumPy, I am importing Matplotlib, and I am importing pandas. Let's run this cell to import these necessary Python libraries. Now it's time to create a data from sklearn. So here I am not using any external data, rather I am creating a data using sklearn.datasets, and I am using a function make underscore blob. Now this is the same dataset which I used in the project 1 of k-means clustering. So all the steps are same. In the project 1 of k-means clustering, we use make blobs function in order to generate the data. So here I am importing make blobs from sklearn.dataset. And now the input parameter to this function make blob are the number of samples, number of features, and random state. So I am generating 200 samples with 2 features, and random state is equals to 42. And you know that the advantage of giving random state is that every time we run this line of code, we will get the same samples of our data. So let's run this cell. So in this way, we have generated a data using a function make underscore blobs, which is present in sklearn.dataset. Now check the type of a data. And we know from our previous section knowledge that this data is of tuple type. And if we want to see the data, we can see that this is a tuple, and this starts with the number of features. So here we have 2 features and we have 200 samples. So we have 200 samples, and after that, we also have labels. But we do not need labels for clustering. We only need these features. Therefore, we will extract the first element from this tuple. So we are passing index 0 to our data to get the feature. So here we have extracted the feature, and now we can see that the type of a feature is numpy ND array. So in this way, we have generated the data. We have generated the data using a function make blob, which is present in sklearn.dataset. So we have successfully extracted the features from this data, which is now in the form of numpy array. Since this is hierarchical clustering, now we have to select the optimal number of clusters. For selecting the optimal number of cluster, now we are going to plot dendrogram. Now, how to plot dendrogram? So for dendrogram, first we will import scipy. Scipy is the scientific Python, and from scipy.cluster.hierarchy, we will import dendrograms and linkage. So these are the 2 important modules which we are going to import from scipy.cluster.hierarchy. So let's run this cell to import these module. Now what linkage is doing and what dendrogram is doing. So first of all, we will study what linkage is doing. So basically linkage calculate the distance and similarities between the sample. So linkage is a function which will find the similarities and which will help us to find the similar data samples so that we can collect them in a cluster. So it has 3 input parameters. First is the feature or data. Second is a method, and third is a metric, which is Euclidean. So basically we are going to use Euclidean distance for this hierarchical clustering algorithm, and the method is ward. Ward basically minimize the variance. If you see here, ward minimize the variance inside the cluster. So basically this is a minimum criteria. You know from theory lectures that in hierarchical clustering, we have a maximum distance criteria and a minimum distance criteria. So here by selecting a method is equals to ward, we are using a minimum distance criteria, and the distance which we are going to use is Euclidean distance. So in this way, we are creating a linkage between the dataset using a method called ward and using a metric called Euclidean distance. So here the linkage between the data is created. Now we will use this linkage data and we will pass this linkage data into a function known as dendrogram. So this function will calculate and it will plot dendrogram for us. Here we are plotting a dendrogram. So we have created a linkage between the data points and we have created a dendrogram. Let's run this cell to see the dendrogram. Now here is the dendrogram, and now from this dendrogram we have to see how many optimal clusters are there. Now the dendrograms are always tricky and we have to be careful while selecting the optimal number of cluster. Here we have to select or we have to set the threshold. If you remember from the lectures in theory, in order to set the threshold, first we have to find the vertical line of maximum length, which should not be crossed by any horizontal line. So basically, if we see this is the vertical line of maximum length, but we cannot select this line for a threshold because it is interfere or crossed by this horizontal line. The other three possible lines are this line, this line, and this line. So what we can do, now we have to select that whether this line is of high distance or of more length, or this line is of more length. So both these three lines, basically this line and this line are of same length. So basically this line and this line both can be qualified for a threshold. So we can see that the length of this line is more as compared to the length of this line. So in this case, we can select either this line or this line as a threshold. So we start thresholding from here, and then we will cross across the dendrogram. So if we cross across the dendrogram at this point, now we can see that under this threshold line, if we assume that our threshold is here, so the below this line, we have three vertical lines. It means it is safe to take this as a one cluster, this as a second cluster, and this as a third cluster. So dendrogram is used to find the optimal number of cluster. And here with the dendrogram, we have decided to take 3 cluster for this particular project. Now it's time to apply hierarchical clustering to train the model. So first of all, we will import hierarchical or agglomerative clustering, which is the important type of hierarchical clustering from sklearn.cluster. And here we are giving number of cluster is equals to 3. So here for the agglomerative clustering module, we need only one input, which is number of cluster, and that is equals to 3. Here we are fitting and getting the predictions from our features. So let's run this cell. These are our predictions, and we can see that there are only 3 integers value 0, 1, and 2, because we have decided that we will divide our data into 3 clusters. 0 indicate the first cluster, 1 indicate the second cluster, and 2 indicates the third cluster. Now it's time to visualize the cluster. So here we are plotting the first cluster. So this line of code in this cell, the line of code is exactly the same. All the lines of code are actually exactly the same, which we saw in k-means clustering section. So here we are plotting our first cluster, then a second cluster, and then a third cluster. Let's run this cell. So we can see that these 3 clusters are obtained, and these clusters are separated very well from each other. The points in these clusters are tightly bound with their clusters. So in this way, we have applied agglomerative clustering, which is the type of hierarchical clustering in our project 1. And we have divided our data into 3 clusters, and we select number of cluster is equals to 3 with the help of dendrograms. Now, if you remember, student, there is a metric known as silhouette distance, which is used to evaluate the performance of hierarchical clustering. Now it's time to evaluate the performance of this hierarchical clustering. So basically, we have selected 3 clusters from the dendrogram. So in the theory section, we have seen that dendrograms can be tricky and can be misleading. So now it's time to check whether we have selected the optimal number of cluster correctly, or we have to go back and change the number of cluster. For this, we have to calculate a silhouette distance, which is a metric to evaluate hierarchical clustering, and we have to calculate the silhouette score. This silhouette score or silhouette distance or a silhouette score is present in sklearn.metrics. So let's run this cell to import this score. And here we are calculating the score for n is equals to 3. Since we have 3 clusters, let's run this cell and see. Now this score is 0.846. And we have seen from a theory lecture that its maximum possible value is 1. So this value is close to 1. It means this is a very good score. Let's calculate silhouette score for 2 cluster as well. So here I am passing number of cluster is equals to 2. Here I am getting the predictions, and here I am calculating the silhouette score. So if you see silhouette score, it needs 2 input, the features and the predictions. So for 2 cluster, we have calculated the predictions, and now it's time to calculate the silhouette score. Let's run this cell and see. So we can see that this value is 0.70, which is less than 0.84. This value is also good. It means if we go back to the dendrogram, we could have also taken the 2 cluster. So if we take two cluster, it means that that could be the one cluster and that could be the second cluster. But the thing is, the selecting a number of cluster 3 is a right choice because it has a high select score. The select score for two cluster is also good. Let's check the select score for four cluster. So here I am passing number of cluster is equals to 4 to the agglomerative clustering. So we can see that this value is even less than n is equals to 2 or for 2 cluster as well. Now it's time to check for a 5 cluster. So here I am passing number of cluster is equals to 5, and we can see that the value is very less, even less than 0.5. So we have seen that for number of cluster is equals to 3, silhouette score is high. It means our selection was right from the dendrogram. So in this section, in this lecture, we basically learn how to implement the agglomerative clustering, which is the most important type of the hierarchical clustering in Python. We generated the data with the help of a function make block, and then we plot the dendrogram. From the dendrogram, we select the optimal number of clustering, and then we plot the cluster and calculate the silhouette score. We see that for number of cluster is equals to 3, the silhouette score was very high. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So this lecture is a continuation of our previous lecture. So we are still in project 1 of hierarchical clustering. So actually what we have done till now in project 1. So basically we have completed the project 1. We have generated the data. We have successfully implemented hierarchical clustering in Python. Now we have to discuss few more things with respect to this project. So we have generated the data in this project with the help of a function make underscore blob. Here the third input was a random state is equals to 42. So the advantage of giving input a random state is that every time you run this line of code, you will get the same data sample. Now there is another advantage if I remove this random state. So what will happen if I remove this random state and I generate a data? Every time I run this cell, I will be able to see different data sample. Here the type is same, but if I see, I will see the different data sample. So if you see the data sample here, the data sample in the top row are 4.39 and minus 5.16. So if I run this cell again, you can see it will be changed. So you can see that these samples are changed. So these samples are now 6.88 and minus 5.33. Previously, there was 4 point something here. Now, what is the advantage of doing this? So basically, every time you run this line of code, you will get a new data set and you will plot a new dendrogram and you will see new cluster. So the advantage of generating this data with the help of sklearn dataset and a function make blob is that if you do not pass a random state, every time you run this cell, you will generate a new data set. So you can practice a lot by generating a new data set every time. You can see the different shapes of dendrograms. You can see the different type of clusters here. So if I scroll down and I run this project again, so here are my features and here is the dendrogram. So if I run this cell again, and if I see the dendrogram now we can see that in this dendrogram, either we can select 2 clusters or we can select 3 clusters. If we see that this is the line of maximum vertical length, which do not cross any horizontal line. Therefore, we will select the threshold value somewhere here. So if this is my threshold line, and if I go below this threshold line, I may have this 1 cluster, 2 cluster, or 3 cluster. Now here we may have 1 cluster and 2 cluster and also 3 cluster. Now how many cluster we need to select? Suppose I start with 3 cluster, and in order to verify that my selection is correct, then I will have to calculate the silhouette score. So I am starting with 3 clusters now. So I am starting with 3 cluster. Here are my predictions, and let's plot these cluster. So if we plot this cluster, we see that our choice might not be a good, and we may have 2 cluster. So this might be a one cluster and this might be another cluster, but we have selected number of cluster is equals to 3. So let's move on and calculate the Silhouette score for number of cluster is equals to 3. So if I run this cell and calculate the Silhouette score for n is equals to 3, the Silhouette score is 0.4849. This score is very less. It is not close to 1. Let's run this or calculate the Silhouette score for number of cluster is equals to 2. If I run this, now this score is very high. It means I have selected the wrong number of cluster from the dendrogram. And we have repeatedly said in the lecture, in the theory lecture and in the project 1 also, which was the previous lecture, that dendrogram might be tricky. So you don't need to worry about if you feel any confusion while selecting the optimal number of cluster from the dendrogram. You can select the number of cluster according to your calculation, and then you can verify with the help of Silhouette score. So here we can see that this value is less, and for number of cluster is equals to 2, Silhouette score is high. What about the number of cluster is equals to 4? So this value is also less, and for number of cluster is equals to 5, this value. It means we should have selected 2 cluster for this. And from here we can see that this should be our first cluster and this should be our second cluster. So you have seen that if we selected the number of cluster wrongly, or if we selected the number of cluster correctly, we should be verify with the help of Silhouette score. The Silhouette score should be close to 1, or the highest value of a Silhouette score should be selected. So in this way, if we go back and if we run this whole program again from here, runtime, run all, and we can see that we might get a different dendrogram here. So you can see here the dendrogram is now different. So this is the advantage of generating a data from sklearn.dataset. Every time you generate the data, it means you are generating a new data set and you will see a new dendrogram which will be helpful for your practice. Now, where is the threshold layer? So this line is a threshold layer because this is the vertical line which do not cross any horizontal line. If I select this, I cannot take this as a maximum vertical line because this horizontal line, if it extended, it will cross this vertical line. So my threshold is somewhere here. So my threshold is somewhere here. So in that case, there will be 3 clusters now. Now, look at the values of these cluster. Now we can see that a 3 cluster is a good choice. Those 3 clusters are very well separated. And if we see the Silhouette score for number of cluster is equals to 3, the Silhouette score is 0.75. For 2, it is 0.55. For 4, it is 0.61. And for 5 cluster, it is 0.45. So we can see that this time number of cluster is equals to 3 is again a right choice. So student, I request you to play around with this project. Keep running this project again and again, and you will see every time a new dendrogram. So that will help you to get full understanding of a dendrogram, and you will learn how to select the optimal number of cluster. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So this is the time to start project 2 on hierarchical clustering. So here is my project 2 on hierarchical clustering. If I click on this file, I will be able to open it in Google Colab environment. So here I am at my project 2. So I need these Python libraries for my project 2. So these libraries are NumPy, Matplotlib, and Pandas. Let's run this cell to import these Python libraries. So in this particular project, which is project 2 on hierarchical clustering, I am not going to generate any data from sklearn.datasets. Rather, I am importing a dataset which is present in my folder. And we know that in order to import any dataset from the folder, we need to mount the drive and we need to set a path. So in order to save the time for this lecture, I have already mounted the drive. You can see that drive has already been mounted, and I have already set a path so that I can read my dataset successfully. So here is my dataset, mall_customer dataset. You have already seen this dataset in the project 2 of k-means clustering. So let's run this cell to read the data. So we can see that this data has 5 columns or 5 features: the customer ID, the gender, the age, the annual income, and the spending score. Since we need to plot the cluster and we need to visualize the cluster, so in order to visualize the cluster better, we will select only 2 features from these 5 features. And those 2 features will be the annual income and the spending score. So here I have extracted those 2 features. We can see that we have extracted those 2 features, which are annual income and spending score. Now it's time to get the dendrograms so that we can select the optimal number of cluster. So I am importing SciPy, which is a scientific Python. Then from scipy.cluster.hierarchy, I am importing dendrogram and linkage. Let's run this cell to import these important modules, dendrogram and linkage. Here I am creating a linkage between the data sample of a data. The metric I am using is Euclidean distance, and I am using a minimum distance criteria. And here I am plotting the dendrogram. Let's run this cell to see the dendrogram. Now we can see that this is a dendrogram, and this can be a very tricky and misleading. Now the first step after observing the dendrogram is to select the threshold value. For selecting the threshold value, we need to see a vertical line of maximum length. So if I see this line is of maximum length and this vertical line is also of maximum length, but there is a problem that if I extend this horizontal line, or this horizontal line, these line will pass through this vertical line. So it is not fulfilling the requirement of thresholding. After this, I have this line, this vertical line, which is of maximum length, but I cannot select this because this horizontal line, and this horizontal line will interfere this vertical line. So I cannot also select this vertical line. Then there is this vertical line, which is in light blue color. So we can see that if I extend this horizontal line, it will interfere this vertical line. So I cannot also select this vertical line. So I am left with this line or this line. So I cannot select this vertical line because if I extend this horizontal line, it will cut or it will interfere this vertical line. So now I am left with this vertical line. So if I see this vertical line, throughout its length, there is no horizontal line which is passing through this vertical line. So I will select my threshold here and I will extend this threshold throughout or across the dendrogram. So here is my threshold. So if we assume a threshold line here, and if we see below this threshold line, I have 5 vertical lines below this threshold line. This is 1, this is 2, this is 3, this is 4, this is 5. So based on this, that I have 5 vertical lines below my threshold, I am going to select 5 number of cluster for this particular project. So now I have selected number of cluster is equals to 5. And here I am getting the predictions. And now I want to visualize these clusters. So this code, the code present in this cell and the code present in this cell is exactly the same code which we saw in the project 1. Here the number of clusters are 5. So let's visualize the cluster. So we can see that these are the 5 clusters. And with the separation of the cluster, we can realize that the selection of 5 cluster is not a bad choice. But we have to justify our choice with the help of Silhouette score. Now it's time to calculate the Silhouette score first for n is equals to 5. So first we need to import Silhouette score from sklearn.matrix. Here I am calculating the Silhouette score for 5 clusters. Here I am calculating the Silhouette score for 4 clusters. And now it's time to calculate for 3 clusters. If I compare the Silhouette score, I can see that the Silhouette score for 5 cluster is higher than any other number of cluster. It means our choice was correct. We have selected the best number of clusters from the dendrogram or the optimal number of cluster from the dendrogram. And we have justified our selection by calculating the Silhouette score for n is equals to 5. So student, dendrogram can be tricky. You need to set the threshold very carefully. And after setting the threshold, you have to select the optimal number of cluster. If you select the number of cluster which are not right, even then you don't need to worry about you can always go and calculate a Silhouette score and you can correct your selection. So in this lecture, we see how to implement hierarchical clustering on a dataset known as customer dataset, and we can see that the dendrogram of this dataset was very challenging. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture. Hi everyone, welcome to this lecture. So this is the time to solve project 3 on hierarchical clustering. So here I am at project 3. If I click on this file, I will be able to open it in my Google Colab environment. So click on this file. So here I am at my Google Colab. So for this project 3, I need NumPy, I need Matplotlib, and I need Pandas. So let's run this cell to import these important Python libraries. Now here I am creating a random data. So I am creating the same random data which I created in the project 3 of a k-mean clustering. So this code is exactly the same which I explained you in the project 3 of a k-mean clustering. So if you remember, the first step was to create 6 different data sets, and the size of each data set was 200 by 1. That is, we have 1 feature and 200 samples. Now from these 6 different data sets, we created the 3 data sets. And here we created 3 data sets by horizontal stacking of the first 2 data sets, that is X1 and X2. Then horizontal stacking of the next 2 data sets, that is X3 and X4. And then again horizontal stacking of the next 2 data sets, that is X5 and X6. So in this way, we transform these 6 data sets into 3 data sets. And the final step was to combine or vertically stacking these 3 data sets to form a final data set. So let's run this all cell to generate the data. So this was a first cell of the data, the second cell, and we can see that this is our X1, and we can see that it has 200 samples and it has 2 features. X1, X2, X3, X4, X5, X6, all these 6 data sets have 1 feature only. When we do a horizontal stacking, we will get 2 features each of X1, X2, and X3. So if I want to check the shape of the data, it should be 200 by 2 now. So if I scroll down, I can see the shape of the data is 200 by 2. Now this is my final data which I obtained by vertical stacking of X1, X2, and X3. Now since this is a vertical stacking, the shape should be 600 by 2. If I run this cell, I can see that the shape of my feature is 600 by 2 for this project 3. So this is not a new thing, that how we generated our data for this project. We have already did this in the project 3 of k-means clustering. Now we are here in hierarchical clustering. Now it's time to plot dendrograms or to draw the dendrogram so that we can find the optimal number of cluster. So here I have imported the scientific Python, the SciPy. From scipy.cluster.hierarchy, I have imported dendrogram and linkage. Let's run this cell, and here I am plotting dendrogram. So if I see a dendrogram, this look as simple. This doesn't look very tricky. Now I have to set a threshold. So this is the vertical line of maximum length. But if I see this horizontal line, and if I extend this horizontal line, it will cross this vertical line. So based on this, I cannot select this vertical line for threshold. Now, the other 2 lines are these lines and these lines. If I see the length of this line is greater than this line. So the question is, can I select this line for a thresholding? So I can see that there is no horizontal line which interfere this line. So this line or this line which are equal in length can be selected for the thresholding. So here is my threshold. So my threshold is here. And if I see below my threshold, there are 3 vertical lines. So this is cluster 1, this should be the cluster 2, and this is a cluster 3. So basically, based on my thresholding, I am going to select 3 clusters for this project. So here I am applying the agglomerative clustering, and I am getting the predictions for number of cluster is equals to 3. So let's run this cell to get the predictions. So here we get the predictions, and now it's time to visualize the clusters. So we can see that we have 3 clusters now. Now, we have to justify our selection by calculating a silhouette score. There might be a possibility that the selection of two cluster also works here, because we can see that this red cluster and this green cluster are trying to overlap each other. So we have to justify our selection of selecting three cluster. So we will calculate a silhouette score first. So here we are importing a silhouette score from sklearn.matrix. And here we are calculating silhouette score. The input are the features and the predictions. Let's run this cell. So we can see that this value is quite reasonable. It is close to 0.7. Let's calculate the silhouette score for two clusters as well. So for the two cluster, this value is 0.6. And for four cluster, this value is less than 0.6. So we can see that our selection was right. And we have rightly selected the number of cluster from the dendrograms. And it is also verified with the help of silhouette score. So in this project, we used another dataset, the third dataset. Basically, we generated this dataset using numpy.random.randn command. And after generating the dataset, we get the dendrograms, and from the dendrogram, we get the maximum or the optimal number of cluster. So I hope you understood this project. Thanks for listening, and I will see you in the next lecture.